Hi everyone, good morning. Thank you so much for the organizing committee for organizing this machine learning summit, and thanks for inviting me here to talk about. And I work in Ericsson Research Artificial Intelligence as a senior project manager, and it's based in Chester. And then as a researcher, we just not work on developing the new AI technologies and push the boundaries of the AI through the thought leadership, but we also apply it heavily in our telecommunication networks. And that is the topic of today's talk also, why AI is so important for the telecommunications domain in general, and then how we are applying it in our services and products, and which important role the AI is playing, why it's really needing. I will start with a brief introduction about the company, and then I will go into the details and the use cases, very few use cases where we are using AI. I cannot present all the use cases, but we go through some of them. So I think most of you will know Ericsson. It's a world leader in providing information and communication technology and 5G all around the world. We enable connectivity through the service providers. So our customers, basically the connectivity service providers, they are all around the world in 180 countries. And these are some sales figures, which we see that, like, yes, Ericsson is a Swedish giant company, we can say on that, with having more than 100,000 employees all around the world, managing networks, working 24/7 to enable the connectivity. And with that, Ericsson has its own, not just the research part, but very strong R&D and a very strong patent portfolio. And this is the number at the end of 2020, 57,000 patents by the company, and they are like increasing every day. So what Ericsson provides connectivity, and we say that with every new generation of the networks, the new use cases were added there. For example, I'm not going into the complete history. I just start with 1980s, where it started become more and more interesting for us. That in 1980s we started the first generation networks came, and then it was providing the voice services. And then when the 2G came, after 10 years of that, the services started to be heavily digitalized. And then the new services were added at the top of it, for example, SMS, or sometimes you could also be able to check the emails on the phone. But then a new shift came with the 3G in 2000, when the internet surfing started. And in 2010, with the 4G, the mobile broadband services started, and it enabled the use of smartphones to us, and everything like shifted from computers to the phones, and we were able to do many things on the just on the phone devices, which were not possible before. And now from 2020, when we say that the 5G came, then the new thing in the 5G as compared to the previous generations is that it just not connect the people, or not just enable the new businesses on the internet, but it's connecting the machines as well. Sometimes we call them IoT devices, sometimes they are sensors, sometimes we call them connected machines or intelligent machines. For example, if there is an autonomous vehicle which is connected through the cellular connectivity, then that autonomous vehicle will have the intelligence in it, or the robots which are connected. So the robots will be autonomous agents, or the intelligent agents, we call them in the services. And now in research, we have started to work on the 6G. So we have started to work on 6G in Ericsson Research already now, although this will come like in 2030. This was just a brief introduction about the company. I move forward with what's there now. There. Some use cases. This is the first use case which I was working in 2015, and we were working together with the Scania. Scania, you may know, that is a company developing vehicles and buses and trucks. Or and the use case was that there is an autonomous bus moving passengers in the city, and since it's an autonomous bus, there is no driver in the bus, but it's moving automatically on the roads. But situations can come where the autonomous vehicle cannot make the decision by itself. For example, there can be an unplanned road work going on, or some accident can happen. So in those situations, it's relying on a remote driver, which can be sitting like kilometers away in a room or in his office, and that remote driver will drive the vehicle for some period of time and take the vehicle out of that dangerous situation. So that was the use case. So we first identified what are the customer requirements there. So the requirement from the customer sides are to drive the vehicle by a remote operator who is sitting very far. It must send some videos from the front camera of the bus and the side cameras of the bus, and the operator must see those videos in real time. The video should not be lagged, right? And then all the control commands from the rig of the operator, they must be sent to the bus and then operated by the bus. So this was the requirement. So what these customer requirements put the emphasis on the network. So what will be the network requirements? We see that for the network, there could be the first thing is that the bandwidth should be really high, because we are sending multiple videos, and then the videos are not downlink, they are the uplink videos. The usual configurations is that we have more capacity on the downlink as compared to the uplink, but this use case provided us a very different requirement on the network. Then the video should be sent in real time. What real time I mean? It should not be in the seconds, it should be in tens of milliseconds. So it means that the latency of the network should be very low, and then it's a very highly critical use case. Why I'm saying this? Because the safety of the passengers is dependent on that. You can compare it also with another thing, that suppose a passenger sitting inside the bus and surfing the net on the phone or doing anything on the internet, and he also needs the network bandwidth. So what is the criticality of that person's activity as compared to the safety or the life safety of this? So it should be different. So the network of the bus, connecting the bus, should not be hindered by any other activity of any other person who is inside the bus or who is outside the bus. It means we must guarantee this network to the bus at that time. I'm giving you another example, a smart meters use case. And these are the electricity meters which collect the data throughout the month, but once in the month, like towards the end of the month, they have to send all the data of all the meters to the cloud, and where the invoices of the customers are generated and sent back to the customers. So once in a month, we have to send heavy data. So it means it also requires high bandwidth, and it's again high uplink bandwidth, I'm saying. But is it What about the latency requirements there on the networks? Yeah, no, it's not time critical in nature at all. If one packet is dropped, we can send it again. And what about the criticality? No, it's also not safety critical or high critical. It can be less critical. We can, if we can send it during the day, we can send the data during the night or this. So we see that these two examples are connecting the machines or the IoT devices or the intelligent machines to the network. But each use case is presenting a very different quality of service requirement on the network. So what 5G brings, it brings higher data rates, more volume for the data, lower latencies, more devices, less cost, better energy saving, and the better coverage. But these were like the characteristics which every G was providing as compared to the previous G network. But the main thing with the 5G was this diagram below that I'm showing, that it provides the connectivity to different industries through the network slices. So what is the network slice? Network slice means that we divide the network in different slices and we allocate the slice to one particular industry, and in that industry to a particular use case. And in that slice, we guarantee all the quality of service requirements, the throughput requirement, the latency requirement, the criticality requirement. Some use cases will be highly critical, some use cases will be less critical. So when you divide the slice and you isolate the network and its resources for that particular slice, you are able to guarantee the quality of service requirements. So it's one way to enable that part. We can say that this is a paradigm shift in mobile networks. If you see the left part, the 3G and 4G mobile networks, the services there were mobile broadband or voice or messaging. As I said before, the customers were the legacy telecommunication customers, like we are using our mobile phones and subscriptions and private or corporate mobile subscriptions, and that's it. The services were really years-long services there. It means that they were set it up once and manually by the human persons, and then they were just running along unless there was some problem or there is a need to change the services. And they were highly non-automated fashion. What happened with the 5G? With the 5G, in addition to all these legacy customers, we have to provide the network slices with different industries to connect all the connected devices and those parts. The services becomes short or long, so it means that the duration of the services varies. So the services became very dynamic in nature, not just with respect to the quality of service requirements of them, but also with respect to their duration. It means that for each service, we have to do a service level agreement or SLA negotiation or renegotiation, we say that what the service will provide and what will be the price of that service, what will be the guarantees of the service, what will be the duration of the service. All these will be negotiated and renegotiated. Why renegotiated? Because if we say that, okay, this particular service will provide the throughput guarantee this much throughout for 6 months, suppose, then in 6 months, how many times the service was violated? So, and if it's able to provide the guarantees or not, maybe there is need of renegotiation with the customer. So what do you see? Like, can this all be handled in a manual manner? It's not just the problem of extreme complexity. It's also the problem of setting up the services. It's also the scalability. It's also providing differentiated quality of service requirements. So really the automation is the key there, that the automation we need there. And that shifts to that sets the main motivation, like we really need the automation. And then to enable automation, AI is the key, not just for all other industries, but that also holds for the telecommunication industry. I will go through some example use cases for now. So maybe like that give you some flavor how we can apply it, how we are applying it at Ericsson. This is a very short list about what we are doing or where we are applying the AI. We are the first is to apply it to our own telecommunication use cases, but then it's not restricted since the network will be connecting the manufacturing industry or the process industry, also the automotive or transportation domains, and also the health domain or other domains. So the use cases are not just limited to the communication, but the list really goes on. So for the use of AI for the cellular industrial services, we see that in the network, we have quality of service requirements, as I explained, that there are throughput requirements, latency requirements, the reliability requirements, and then how to do that, how to enable that. The enablement is through the orchestration of the network slices, and that is done, that starts from the service level agreements and the service providing different services, agreeing it with the customer in the service level agreements, and they will be highly automated. And all these service and this network slices will be provided to the different industry verticals. From the industry vertical, the application requirements or the industry requirements will be, or the customer requirements, you can also say, will be translated into the KPIs of the network, and then the services of the network will be matched with them. A simple use case, like we start by, suppose, roll out the 5G slices. So what we do there, we map the customer requirements to the network requirements, and then we see that how many resources do we have, and these include the hardware resources and also the software resources of the network to meet those network requirements. We synthesize the new slices if they don't exist already, and if the slice template exists already in the network, we just activate the slice, and then like all this is done through the machine reasoning or the AI planning. These techniques we are using there, but that just don't stop there. Throughout the slice life cycle, we have to guarantee that those quality of service requirements are met. And for that, like instead of going in a reactive fashion, that a problem has occurred, we intend to do it in a proactive manner. So we use machine learning based prediction analysis methods, and we predict that whether the SLA is violated in advance. We use XGBoost or neural networks, regression analysis based different algorithms there. For example, you see here that we are here in time where this is written now, and we are doing the prediction analysis, and we see that after some times the prediction says that the SLA will be violated. So once we identify a predicted violation in the future time, we apply different explainable AI methods, for example, LIME and SHARP and LSTM, to identify what is the root cause there. And then once we identify the root cause, we apply machine reasoning based techniques to provide a suitable recommendation that what to do in this particular use case. Sometimes this recommendation goes to the person who will approve that recommendation, and sometimes it will be, and then automatically the actuation will be performed. Then another use case is preventive maintenance and the privacy preservation. We know that there is GDPR, and we don't have, like, we must treat the data privately, so we use federated learning techniques there, so that we don't take the data, we don't work directly on the data. Instead, only the averages are sent, and then in that way the data is preserved, and the machine learning models take advantage of each other. The federated learning is very good AI techniques which we are applying there. And then there are some augmented reality technology which we are using for automated inspection of our devices. For example, this is a cabinet, and then you see that the person is identifying, and then with the overlay layout, he is identifying that whether there is some problem or not in this particular in there. So the problem will be identified automatically, and then a solution will be proposed. Like, what's the solution to this particular problem? These are some use cases which we worked in the previous years. There is the weatherproofing use case. This is a tower which is like very kilometers high. We sent a drone captures the photos, and then at top of the photos, and we apply this overlay, and it identifies that there is a loose clamp shell around the cable, which is the problem. So once we identify the problem, then we can send either a person, or very futuristic, if I say, then in future there should be some special robots which will go up and fix those problems. So there are many other use cases and many other things which we are doing using this AR and VR. So we are using their object detection, image processing, augmented reality, and different machine learning algorithms. And they are really the customized algorithms so that we can use them on our phones or tablets. So they are not very heavy in processing. These are some other examples from smart factories domain. I already provided one example from automotive domain, but I think I really don't have time to go on all those parts. I would like to finalize the presentation by saying that, like, what are the key takeaways? That we see that the networks have entered really a new paradigm domain, a new paradigm shift, that we just not connecting the people, but also connecting the things, or you can call them sensors, or you can call them machines, or you can call them autonomous machines, or sometimes the machines are really intelligent machines or autonomous agents in themselves. And the complexity of the systems are increasing, the complexity, the scalability, so automation is the key, and AI is the key to enable the automation. And that doesn't hold, that also holds for the network industry. So AI is vital for improving the customer service and enhance the customer experience as well, and adopting AI and creating the new challenges, and even it solves the network complexities. And my last slide, I won't really go to the details, but I would only like to show you what in Ericsson research we are doing these days. Since we say that research is always working 10 years ahead of the other company, the other parts of the company, so we have started to look at 6G, that what the 6G will be, which technologies the 6G will be using, which use cases will be there in the 6G. And we are really here today. And we are envisioning our path towards 6G. So the initial 4 parts are the use cases. We say that it will be the Internet of Senses will be the new thing to the 6G. The connected intelligent machines will be more and more connected and intelligent there. The digitalized and programmable physical world, there will be digital twins of each and everything. And the world will be connected and sustainable as well with respect to energy and other aspects. And then how we will enable them. So we will work on these 4 main topics. The connectivity will be limitless so that we can connect all those parts. The systems should be trustworthy, and by trustworthy, I mean that they just not will be private or secure, but all the AI that is used inside the system must be explainable. The network will be cognitive. It will be able to make its own decisions. It will be able to identify its own problems, react on them, recommend the solutions, and actuate to solve the problems. And then the network compute fabric will be there, so that everything will be connected in the real world in the cloud. Yeah, I have provided you some white papers and some links here as well, the 6G white paper and then the explainable AI white paper for that. And I stop here and I leave some time for the questions. I don't see any question here in the question and answer session. Okay, there is a question. How are you managing the value and risks that come with the automation and increasing complexities of the AI? Yes, very good question. But which type of risks will come there? This is the first thing. And then the question comes with the management. And this, with the AI, I clearly see that one particular thing with the AI is that it must be explainable. Maybe you have heard about the recent, not just the GDPR rules, but the European Commission guidelines that the AI, wherever it will be used, it must be explainable. Like we already know the privacy concerns or the security concerns, but there is like explainability here. So we are working on that very proactively, and for that you can go through and read the AI white paper as well, our explainable AI white paper. And then the risks come with automation, that there will be like maybe the machines are making some wrong decisions in an automated fashion and something can go wrong. That is another risk that I see with automation, I say. And there I also say that the explainability of which decisions are made can play an important role. Sometimes there is human in the loop, so the recommended solutions can be provided to the human and the human can choose that part. But if we consider that this is a fully automated system, it must be traceable back. So back tracing through the system made which decision at which point based on which data or which insights is important thing, I would say. Okay, there is an other question by Kapil. Nice use case about autonomous bus. Could you please explain the exact role of AI in this use case? Okay, for example, is it real-time network bandwidth adjustment so as to not disrupt any other product in need of similar capacity in the coverage area? Okay, I presented this use case to motivate that how complex the systems will be, and I also presented the use case to present you that how 5G will provide the quality of service requirement there. And the role of AI is to provide the automatedly the suitable network slice to that particular service. Like customer will say that I need the connectivity for the autonomous bus, but how those how would we know that which latency is needed or which bandwidth is needed? Most of the time customers are slightly less aware about their real network requirements. They know their customer requirements to meet. So we need to translate those customer requirements into the network requirements, and then the AI plays an important role initially in the matchmaking that to this particular network requirement, which network slice is suitable, and then the AI plays an important role in orchestrating that the whole process, that whether we have the resources to meet this customer requirement, how many resources are needed, how many CPUs will be needed, where to allocate, which base stations will it go on, all those things are like in all those parts the AI will be used. I think I'm a bit over time, but there is another question. The weatherproofing use case sounds interesting. Is it an image processing use case to highlight the issue with the loose wire on the tower? Are the drones who take such images are manually flown, or they have an automatic program? Okay, in the weatherproofing use cases, I presented 3-4 use cases actually. Image processing is only one technique. We are also using neural networks, and we are also using AR VR at top of it, and we are sending the drones, and then there are different actually the drones can be sent as an automatic plan as well. There is no problem in that, but there are legal regulations regarding that. For example, we cannot send a drone which is out of sight, so we have to send it manually. So this is a legal limitation, you can say that. For example, it is the same thing that you cannot drive the autonomous vehicle on the road. The driver must be sitting there like this for the safety reason. Maybe he's not driving the autonomous vehicle, but he must be sitting there. So yeah. So I say that they are flown manually, but there is just a legal hurdle. So when the laws will be made, then the automatic plans can be done for that. Any more questions? Thank you, everyone. Then I leave. Take care. Bye.